What is music? Music is audio designed to invoke an emotional response, whether that may be from instruments, vocals, or just everyday objects making noise. So, if music is just noise, what makes it different from just regular audio? In music, sound is organized in time. There is repetition, patterns, and harmony not found in regular audio. Computers are really good at organizing things and keeping time, doing calculations. So that leads us to the next question. Can computers produce music? Music is made through a creative process, which people are really good at doing. That requires being original. The problem is, algorithms are really bad at creating original things, but they are good detecting it. For example, originality checking software Turnitin uses frequencies and patterns in text to find whether submitted work is original or has been directly derived from works elsewhere on the internet, signaling plagiarism. Computers are really good at straight up calculation, so is there any way to quantify this problem? We have to remember audio is just a set of frequencies that we use to make sound. I opened up a waveform in Audacity, a sound editing program, where we can see the amplitude of an audio wave through time. If we zoom in, we can see what are considered derivatives of sine waves. These waves produce a distinct sound at a certain frequency. All audio is composed of waves like these. In order to analyze audio, we need to convert our waveforms into useful data. All periodic waveforms can be decomposed into smaller waves to the point of plain sine waves. When added up, they can approximate the original waveform. We use Fourier transform to transform signals into their periodic frequencies. From this frequency space, we can get key data points about the original audio. All of this is a byproduct of our training data. These days, many developers use neural networks to solve these kinds of problems. But how do they work exactly? Well, nodes interact with data points and find the strongest relationships between the training data, passing it along to other layers of nodes. But how is this all relevant to audio? Here's a model of a basic neural network. On the left, we can consider our inputs to be sound files or waveforms. The layers in the middle are training nodes. The arrowed lines connecting them produce weights that can produce an output on the right side. The right side is our generated audio. The generated audio will have weighted characteristics of our input files. While this is great in theory, neural networks often overfit the data that we give them. This can produce an output that is too similar to the original one. In the context of audio, this can mean that our generated audio, or music, could be very similar to the music that we use in the training data. This goes back to the original problem, the lack of originality. But there's a solution. We can use randomness to make original music. An approach I take is using a format called MIDI. MIDI is a protocol for musical data. It can include instruments, tracks, pitch, intensity, and it's all tracked over time, similar to how a musical composition is placed. I take two popular classical songs, one by Mozart and one by Beethoven, and their MIDI files. The columns represent the frequencies or the notes that are being played. As training data, I average them together, and I introduce a randomness factor into it. The last column represents the data I'll be using for my experiment. I write code in processing, and then add randomness to the source MIDI frequencies in order to better hear and visualize the output. The code analyzes the Excel file. adds randomness, and then plays it. The music didn't exactly sound like Mozart or Beethoven, but it did have elements commonly found in music. This was a very simple experiment. In reality, our source files will not be as clean-cut as MIDI frequencies. Imagine what could be done with a bit of randomness, hundreds of songs off training data, and a neural network with many layers. We can actually produce music. This field is important, and not only for music generation. Similar algorithms can be used for speech generation, such as Google Translate and Siri.
One 98827 80930 28722 383 saying fun is 127
As heard in the video, artificial speech can sound really robotic. Speech is full of tones, so there needs to be a musicality in it, and that requires training data. A similar system, combined with randomness, could be used to generate stories with topics that are related to each other. YouTube uses an audio analysis to identify and sort musical works. They can even successfully identify copyright violations without a touch of a button by a real person. Spotify uses audio analysis to identify elements in tracks you like, and then recommend similar music. Artificially generated audio is a technology that will revolutionize how we produce and consume audio.